Hi, I'm Steve, AD4XT. Welcome back to the channel. Well, I'm going to build a dipole today, a very simple one with limited materials. I'm even going to use a piece of wood for a center connector. Stick with me. You might be asking, why would you go to all the effort to make a center connector out of a piece of wood? Well, the idea came up at field day a couple of years ago. We was in the need of a 20-meter dipole antenna to put up to one of the stations to give an east-west direction instead of the main antenna that was north and south. And we didn't have one, and we didn't even have a center connector. Had some coax, and that's where the ingenuity came up to throw something together real quick. So that's what we did. So let's go over here to the table and look at some other connectors, center connectors that I've used in the past and what we're going to do today. Let's go over a couple of store-bought options you have building a dipole antenna. This is an LDG ready-made one-to-one balun with the screws on top to put your two antenna wires. Very good, has the SO239 chassis connector. Would make a really good dipole antenna. I have not even used it as a dipole antenna because we have built several ladder line type antennas and just used it as a balun and a center connector for the ladder line. But it would make an excellent dipole antenna. Here's another center connector I've used, again with the SO239 connector in the bottom, ready-made to solder up some wires on. Or like I did here, I soldered up a connector and put a wing nut. And I've used that quite a bit in the past for a store-bought center connector. Here's another really neat one. I picked this up at a Ham Fest. It's very lightweight, probably 3D printed. I picked it up at a Ham Fest chassis connector with a big old loop in the top. Very good to go over top of your spider beam mast, and I have built several antennas with those and gave a lot of them away. Moving on to some Homebrew antennas, I have built all of my wire antennas myself. I would say 90+% I have just built from scratch ever since I've been a ham. But this is one, and I think I picked this design up off the internet a long time ago. Is made with a PVC cap and a plug like these two here, and it's a center connector I would say that would be great to leave up for a long time, and I have a wall full of them made like this. It's not super easy, but it's well worth it because it's watertight, and you can string it up again with the SO239 chassis connector, which is the theme of today. The common denominator here is that all of these other antennas, whether it's a Homebrew or a store-bought antenna, had a connection point for your coax. And we was out in the field and didn't have that, so we're going to build it. A piece of wood and a piece of old coax. I want to measure this one out a little bit better than what we did in the field. Kind of cut it into kind of a T shape. All right, that's what we got marked, and I'm gonna go cut that out. Let's go ahead and cut this piece of wood out real quick. May be a little noisy. Now we have something that resembles a T, like a T connector. Okay, we're on the bench. We've got the T cut out, and we need to decide where to drill some holes and what size. All right, the coax is going to come up through this way, and we're using RG 8X coax, and yes, this was an emergency. We made this antenna and we had to cut off the nice pretty connector on the end, the PL259. So we did, and rounded up some 14 gauge stranded copper wire. That's what we're going to size everything up for the holes. I've picked out a drill bit for each one of those, so let's put some holes in it. These holes here will be the strain relief for the coax. And I'm going to come out to the side with an additional hole, actually 2 holes. And I'm going to put a wire tie on that. Sized up a bit here for the element wire, which is 14 gauge. And I'm going to put a couple of holes, again, for strain relief. You don't want them too big and too sloppy, but you want them tight enough and to kind of have a little friction as the wire or the coax goes through. All right, let's figure out the measurements on where we want to cut our wire. I'd like for this antenna to be right in the middle of the general band, and I usually call that 14-280 megahertz. So there's 2 ways to do it, especially the old-fashioned way. You can go 468 divided by the frequency in megahertz. And that gives you the total length of the dipole, the total length. So that'll give you the total length from here to here. What I like to do is I like to cut that in half and use 234 divided by the frequency in megahertz, which is 14.280 for us. And that comes out to 16.38 foot. So I've got some wire that's already cut, but I'm not sure. And you always want some extra. Don't cut it exactly there. Add you another 8 or 10 inches onto that. I've got some wire here I need to stretch out and measure. It's already been pre-made, and it looks like it might be set for that 20 meter band. It's 16, almost 16.6. And notice it's got another 8 or 10 inches wrapped on itself. So every application is different. So depends on where you're mounting it and how high up. All those variables come into play. So hey, let's go with this. This is one leg of the dipole. And the other one measures just about the same. So hey, we've got both of them already cut. Okay, I've got everything cut. Time to install the element wires. Just going to go down through the hole here. This is going to provide the strain relief I needed. Okay, and all of that can be adjusted. And the other side here. And we will adjust all that. So the element wires are on. Let's put the coax. The coax does not have any connector, and I need it to come up here. So I'm going to go down this hole, back up the other side. It goes through nicely, but still has a bit of snugness, which is what I need, and I need to bring it all the way up here where I can connect everything. That looks like we're ready to put it together. Did I say we weren't going to solder it? Yeah, no solder here. From this point, I have got the center connector tied off to this side, and the shield of the coax tied off to this side. And at that point, you could do about anything. Remember, you're in a tight, and you're already struggling for any extra components. You can just put some electrical tape on it. That day, we had electrical tape, but we chose to just use some wire nuts here, some electrical wire nuts. So that's what I'm going to do today. And one over here for the center connector. So there you go. Both of them tied off with a wire nut. You're basically good to go. The other side of the coax does have its connector, so no problem there. One more point. Let me put a wire tie on here. And zip that thing together. So now you've got stress relief on the coax and good stress relief on the element wires. I think at this point, we've got a dipole antenna. At this point, we have our antenna made. An emergency dipole, or whatever you want to call it, ready to go for 20 meters. Should work as good as any 20-meter dipole. And I would like to get out and test it today, but it's July in Georgia, and the afternoon thunderstorms have kicked in a little bit. You can probably hear the rain on the shop roof here. My plan is to make a follow-up video with this antenna. I think I'll take it out on a parts on the air activation, and if it needs tuning, we'll tune it right there with the radio and see what it does. So, yep, testing and tuning for the next video. Anyways, if you got something out of that, hit the like and subscribe button. I'd appreciate it. We'll catch you again on the next Ham Radio Portable. 73, everybody.